Welcome to a board containing an absolute classic circuit. Anybody's journey on the electronics road will come across this, because really when you understand what's going on with this circuit, you have reached a particular level of understanding of basic components. And I hope that by the time we've gone through this, you will have that understanding. It looks very overwhelming, but let's break it down. Look at the blue line here. You'll have seen this on many of the other boards that we have. We've got an ammeter going through an LED and a resistor to control the current going through this transistor, which is behaving like a switch. On this side, we've got exactly the same. We've got the LED, the resistor, the transistor controlling the LED. These two transistors are switched off and on by this red line and this green line. So this red line comes from the positive, it goes through an ammeter so we can see what's going on, through a resistor, and that can give a voltage on this transistor here to turn it on. And the green line can do exactly the same on the transistor here. Now I've put various switches in so we can see what's going on and build up our knowledge of what's happening. The voltmeters at the bottom are showing us the voltages either side of both of these capacitors. But don't worry about the capacitors, because for the moment they are switched off. And in fact, I've switched off the voltage to this transistor here as well. So let's turn the board on. Immediately you can see this LED light has come on, and we've got about 8 milliamps running through this part of the circuit. And because this transistor is switched on, and it's almost like a short, the voltage at this point from ground is virtually zero. Whereas on the other side of the board, we've got no voltage on this part of the transistor. So this transistor is switched off, which means the voltage we've got at this point of the circuit above the transistor is quite high. It's about 3.5 volts. So that's most of our supply. Why it's not all, we're not going to worry about. So when the transistor is switched on, we've got a very low voltage at the top of the transistor, and when the transistor is switched off, we've got a high voltage, and that will come into things in a little while. If I switch this transistor on, you can see the voltage has dropped down to virtually zero. And this light has come on, and we've got current flowing through here. Now, I'm going to introduce this capacitor into the circuit. If I switch this off, we've got 3.5 volts on this side of the capacitor, and on this side we can see we've got about 3/4 of a volt. So the difference between the two sides in rough terms is 3 volts. And if I switch it on, watch the green light. It flashed on as current came down here and charged up this capacitor. You can think of this capacitor like an old rechargeable battery which can't hold a lot of charge. But that is now charged, and the difference in voltage across these 2 points, as I say, is approximately 3 volts. Now in a moment, I'm going to switch on this transistor, and that's going to change the voltage here. But before I do it, I'm just going to press this button down, and that breaks the circuit here. We've no longer got the connection from the top, but we can still see we've got most of 1 volt on this side of the capacitor, and that voltage is being held there by the capacitor. So let's see what happens when I turn on this transistor. The voltage here has dropped to 0, and we've still got 3 volts less on that side. And we can see that on this meter here. Now voltage is relative, so think of it as 3 volts less rather than a minus value. Now it's going to hold the voltage there until I release the button. But note what's happened. Because this voltage has dropped, the transistor has switched off. So let's just go through that again. We had 3 volts across the capacitor, and when we switched on the transistor, the voltage dropped to 0, so the other side of the capacitor was holding the voltage 3 volts lower than its other side. So we have a voltage lower than ground. Now when I release this button, current goes through this resistor, through the capacitor to ground, and what it's going to do is reduce the voltage in this capacitor. It's going to be charging it the opposite way. So to start with, it's going to be kicking off the charge on the positive side, reducing the voltage across it from 3 down to 0, and then actually charging it the other way, because this was the best part of 1 volt. So let's watch the voltmeter when I release the button. There it goes, it's climbing back up, and it's going to get back to just under 1 volt. And when it got back up to that voltage, the transistor turned on. So quite a lot's happening there. When this transistor was switched off, the capacitor charged, so there was a voltage across it. When the transistor was switched on, the voltage at this point dropped, making this voltage so low that it turned off the transistor, but the charging through the resistor here brought the voltage back up after a period of time. So, turning the transistor on turned this transistor off for a period of time. Now if I turn on this capacitor, it will mean that when the transistor turns on, it will turn this transistor off for a short period of time, and it will flip-flop. Here we go. So the voltage is climbing here, so now we've got this one coming on, which has turned the red light off. That's now come on, which is turning this one off. So we can see the voltage is climbing as the capacitor is charged. We can see the change of voltage on the outsides as the transistors get switched off and on. Now, over here, I've got a little pocket oscilloscope which is giving us the voltage across the capacitor here. So you can see it's going positive, and then it's being pulled down to just below 0. I'll hold it. There we go, it stopped it. So it's climbing up pretty quickly to having the 3 volts across it. It then decays as it's charged by the resistor. It goes to below 0 because this is higher voltage than this one here. But then when the transistor is turned off, then it's charged again by the other resistor. If I lost you during that explanation, go through the previous videos on the ones talking about transistors, capacitors, and if necessary, resistors as well. Now, just the last thing to say is that the speed of which this flip-flops can be changed by two components, the capacitors and also the resistors. And if I slide these up, then it's changing the value of these two resistors, and our oscillation, as we call it, is happening quicker. So there we are, the flip-flop multivibrator transistor circuit.